Good morning. We will discuss arch dam today. Arch dam will be curvilinear. It will be a curve. It will have the convex part towards the upstream side. So the central curvature of the arch will be on the downstream side. So here the dam resists the external forces. The external forces are the same, whether it is a gravity dam or whether it is an arch dam or whatever may be the type of the dam according to the material. The external forces acting on the dam is the same. Here the dam resists the external forces by the arch action. Arch action is a typical structural action to resist loads, external forces. Let us see here, this is a plane element. This is a plane element, you can see. When I apply a force, it sags. When I apply a force, it sags. Suppose I keep this as an arch. Same thing, element. I keep it an arch and apply a force, it doesn't sag. So what happens here is, when I apply a load, this load is transmitted through the body of the arch to these two. They are called the supports. In the terms of arch, they are called the abutments. So when I apply a load, this load is being transferred as axial thrust. Axial thrust along the periphery of the arch, along the center line of the arch. Normal thrust will be perpendicular to that. So there will be two things. One is the radial thrust, another is the normal thrust. So this thrust will be transferred to the supports. Supports in practical case is called the abutment. So this arch will be held by the abutments, very strong abutments. That is the thing. When you select a dam where the dam is going to be an arch dam, the abutments have to be very strong because the external pressure coming on the arch is transmitted to the abutments. So the abutments should be in a position to hold the thrust. So the abutment should be as strong as possible. So this is the upstream side of the dam and this is the downstream side. So here you will have the center of curvature. See, convexity is at the upstream side. And when load comes, it resists and the load is getting transferred to the abutments. There are four types of arches according to their geometry. One is constant radius arch. Constant radius arch. Whatever may be the height, the radius of the arch will be the same. Constant radius arch. Another is constant angle arch, angle of subtence. If you just join a line from this abutment to the center of curvature, this abutment to the center of curvature, that angle, subtended angle from top to bottom of the arch will be the same. Constant angle arch dam. Another is the variable radius arch dam. Variable radius arch dam. So constant radius arch dam, variable radius arch dam, constant angle arch dam, and doubly curved arch dams. Doubly curved. So now the curvature is only in the plane, only in the horizontal plane. If the curvature is there in the vertical plane also, arch can have a double curvature in the vertical plane as well as in the horizontal plane. That will be more strong. It will be more strong because wherever you have a curvature against the external force, that arch action will come into picture and it can take that force very effectively. So doubly curved arch, constant angle arch, constant radius arch, and variable radius arch. So this is the arch dam. Now Arch dam usually will be of concrete. Arch dam will be concrete. Concrete is very versatile. It's a very versatile material to take compression. To take compression, usually the thrust will be compressive in nature. So concrete dams, arch dams will be of concrete. And the site where you have an arch dam will be just like a catenary, just like a, you would have seen the bee hives. It will be taking a, it's a tensile structure, it will be taking a shape, not exactly V, but a shape of a catenary, of a catenary. So you will have a valley in this form and you will have an arch in the valley. Suppose you have the valley like this, you have the arch like this. That side is water, this side upstream. So it will hold, the dam will be like this. Like that, starting from bottom to top. Usually the base width, as you said, base width is subjected to the maximum stress. So base width will have more thickness. Come to the top. But it will be this shape. Bottom thickness will be more, base thickness will be more, but the width in the other direction. From the down, if you look from the downstream towards the dam, it will have lesser width going on increasing at the top. But the thickness will be more at the bottom, will going on reduced at the top. So that is the arch dam. So you see the gravity dam and then arch dam. So in a direct irrigation system, the first hydraulic structure is a dam, and we have seen to a reasonable time regarding the performance of dams in service. Then another type of structure coming along with the river and the canal. I told you canal will be there on the left side of the river as well as the right side of the river. The left side of the river is called left bank canal, and right side of the river it is called right bank canal. Both canals will have supply of water from the dam through the under sluices, through the pipes. So when the pipe is on, you will adjust the pipe with a definite velocity by which water will come from the upstream of the dam to the canal, head of the canal. At that time, you just imagine that you have a canal parallel to the river. So water comes to the canal. You have to adjust the flow of water and the discharge to the canal. So you will have a cross regulator and a head regulator. So across the canal, you will have a regulator known as cross regulator, and along the bank of the canal, the bund of the canal, you will have a regulator known as head regulator. This connection, this pair of this head regulator and the cross regulator is called diversion headwork. Diversion headwork. So water comes from the upstream side of the dam, it enters the canal, the required water will go to the canal by adjusting the cross regulator, and excess water will come to the river. So river will have water not by opening the shutter of the dam. Shutter of the dam will be opened only when high floods are there. But you can divert some water which is coming to the canal through the head regulator to the river. So head regulator supplies water to the river and cross regulator supplies water to the canal. So another component is the diversion network, a pair of head regulator and cross regulator. Another hydraulic structure which comes along the canal in the direct irrigation system. Canal runs kilometers. Long stretch of canals, branch canals also they run, field channels they run. So in the canal, you have, usually canal will be trapezoidal in shape. Will have a bed of the canal, the bottom point of the canal, or the base of the canal. If you take the longitudinal line of the canal, this is the longitudinal line, it is gradually sloping. Because of gravity, there will be a small slope facilitating the flow of water. Sometimes the bed will be like this. That is, some portion of the bed will be like this, then there will be a depression, then again bed. So it will be just like a step. One bed like this, then the depression, then a step. It is a stepped portion of the bed. So if you don't take care of this stepped portion, there will be considerable erosion of the bed. Bed will get eroded. So you have to protect the canal bed where the bed levels are abruptly changing. The bed levels are gradually going, problem will not be there. But if the bed levels are abruptly changing, you should provide a hydraulic structure there facilitating the water not covering the bed. And that structure is called canal drop. Canal drop. So you have a masonry, usually a masonry structure, well protected, protecting the level difference, and you have a notch like thing, a notch. So through the notch, just like this, one or two, a pair of notches will be there. Through the notches, water will fall to the depressed part. And since water is falling, as you have seen, it is just like a miniature dam. So water comes and hits the bed. There is a possibility of water eroding the bed. So you will again have not that much extensive as a stilling basin, but there will be a small water cushion known as cistern. So a canal drop will have what are things? It will have a body wall, then a notch. To hold the notch, you will have the notch pier. Everything will be made of masonry. You can do it. Notch pier. And to facilitate transition, smooth transition, the sides of the notches will be curved. So there will not be eddies. Eddies are nothing but back current. Flow getting reversed. So to avoid that, you will have very smooth transition. Smooth transition, curvilinear transition. So water goes very smoothly to the downstream side. So notch, to hold the notch piers, they are resting on the body wall of the canal drop. Then water should fall little away from the body wall. So for that, you will be just providing on the base of the notch a lip, a tongue-like thing, a lip, a small projection. So once that projection comes, instead of water falling here, water will come here and fall like this. And a small hydraulic jump will be formed. Water comes like this, falls, and small water will fall the cistern. So you have the components of a canal drop are a cistern, a lip on the notch, then a trapezoidal notch, then a notch pier to hold the notch resting on the body of the canal drop. So canal drop is to negotiate abrupt changes in the bed of the running canal drop. Then another thing is the sluices, direct sluices. Direct sluices are usually for supplying water to the agricultural land. Direct sluices supply water to the agricultural land. It is nothing but a pipe across the bund of the canal. You have sluices on both sides of the bank wherever you have an agricultural land. Wherever you have an agricultural land, you have pipes. These pipes will be operated by shutters. You will have shutters. If you close the shutter, pipe will be off. pipe will be closed. When you open the shutter, you can open the shutter according to the water requirement. So direct sluices will be embedded in masonry or concrete and it will be closed. So direct sluice is another hydraulic structure. The same thing in tank irrigation, it is called a tank sluice. So tank sluice, the design of tank sluice is little involved compared to the direct sluice. In a tank irrigation, the tank sluice will have a well at the upstream side, a well at the downstream side, and they will be connected by a sluice. So water comes to the well, then goes to that tank sluice with the tower head and tank sluice without the tower head. So you have a little more protections on both sides of the tank. So water will not directly come to the pipeline. You will have a tower head in which water will come in incoming water, then take the sluice below the bund, then goes to the, that is known as a tank sluice. So tank sluice will be usually there sluices to outlet water from the tank. Direct sluice is to outlet water from the canal. We will discuss tomorrow. Thank you very much. God bless.